Welcome to the deep dive. Today we're getting into something really fascinating, the world of microrobotics.
It's a pretty wild field.
Yeah, we've got this great article looking at the latest stuff coming out of labs, MIT, Harvard,
Yeah.
building these insect-sized robots.
The cutting edge.
So the plan is to unpack what these tiny machines can actually do now and maybe where they're headed. Some of the engineering is just incredible.
Absolutely. I mean, the first thing that hits you is just the sheer scale we're talking about.
Right. How small are we talking?
Think robots the size of a bee. Some even smaller. We're talking lighter than, say, 2 Cheerios.
Wow. That's hard to even picture mechanically.
Exactly. It pushes what you think is possible.
And they move, right. The article mentions some pretty crazy speeds.
Oh, yeah. Some can fly by flapping wings like 250 times a second.
250 times per second.
Per second. And others can swim, doing about 9 flaps per second underwater.
Okay, but wait, swimming, when something that small just gets stuck on the surface, water tension and all that?
That's a huge challenge. Yeah.
Yeah.
Surface tension is like a wall at that scale.
So how do they get around that?
Well, some really ingenious solutions.
Yeah.
One robot uses a tiny bit of combustion, a sort of mini explosion, just to break through the surface.
No way, like a little rocket jump.
Kind of. Another uses electricity to change its buoyancy, basically, to make itself sink.
That's clever. So the engineering challenges aren't just about being small, but dealing with physics differently.
Precisely. And building them.
Yeah.
You can't just shrink down a normal motor, right?
Right, I was wondering about that. How do you make them move?
They're using things like piezoelectric crystals. You apply electricity, they vibrate or bend.
Ah, okay, so that vibration becomes movement.
Yeah, or these new soft polymers, almost like artificial muscles. Some can even self-heal if they get damaged slightly.
Self-healing robots.
Yeah.
That's starting to sound like sci-fi.
It's getting there. It's a whole different way of thinking about mechanics and materials.
The article mentioned flight too. They flap like bees, but it said it wasn't exactly graceful.
Right, aerodynamics work differently when you're that small. They aren't really flying like a plane or even a bird.
So what are they doing?
They create these tiny, super fast swirling pockets of air vortices above their wings that gives them lift.
Okay, more like quick bursts of lift for maneuvering, not for, like, soaring.
Exactly. Very agile, but not efficient for long distances in the air.
Okay, let's talk applications. What are these little things actually doing out in the world or close to it?
Think about inspecting the inside of jet engines.
Yeah.
Tight spaces, metal surfaces. It's perfect for that kind of thing.
Okay, that makes sense. Any others?
Well, there are hopping robots, too. Hopping takes way less energy than flying for covering ground.
Ah, for longer missions, maybe?
Potentially. People are even thinking about using them on, say, Mars.
Yeah.
More energy efficient for exploring.
Interesting. So the early idea was maybe robotic bees for pollination, right? But it sounds like that's shifted.
Yeah, that seems to be the case. The whole robot bee idea really caught people's imagination,
Definitely.
But the practical side, engineering thousands, millions of them, deploying them reliably.
Yeah.
It's just incredibly difficult.
So the focus is more on things like inspection.
Exactly. Inspection, search and rescue in collapsed buildings, places humans can't easily or safely go, checking pipelines from the inside, that kind of thing.
And power. You mentioned that's a challenge, but the article talked about tiny engines, like combustion engines.
Yeah, penny-sized combustion engines. It's amazing.
Wow. That must give them a real boost.
Huge boost. They allow these tiny robots, maybe just over a gram, to carry more or perform bigger actions like jumping really high, maybe 2 feet.
A gram-sized robot jumping 2 feet.
Yep. Opens up a lot more possibilities for what they can do.
So there are these practical applications driving things, but is it just about solving problems, or is there something else pushing the innovation?
I think it's definitely both. There are clear, practical goals, absolutely. But there's also just this fundamental curiosity, right?
Pushing the limits.
Yeah, pushing the boundaries of engineering, seeing what's possible at these tiny scales just because we can try. It's that creativity aspect, too.
Okay, so wrapping this up, what are the big takeaways from this deep dive into the world of microrobots?
Well, I'd say first, the field is moving fast. Engineers are overcoming really fundamental challenges.
Uh-huh.
Second, we're seeing these tiny, agile robots with real potential, moving beyond just theory.
From inspection to maybe even space.
Right. Industrial inspection, disaster response, maybe planetary exploration down the line.
Yeah.
The applications are diversifying.
It really makes you think, as these things get smarter, maybe more autonomous, what other unexpected jobs could they end up doing?
That's the big question, isn't it? What comes next? And what new challenges or even ethical questions pop up as they get more capable?
Definitely something to keep an eye on. Thanks, this was fascinating.